Hello everyone, in this video we want to make a virtual lab to test what is the relationship between the wavelength and frequency and between wavelength and amplitude. Now we listen carefully what are the things that we're going to use and how we will do this experiment. Write down every single step that we are doing and the data you have to record it and the tables. Listen carefully.
In this investigation of sound waves, you'll explore the relationships between wavelength and frequency and between wavelength and amplitude. In addition, you'll explore the effect that each variable has on how we hear sound. Here's what you'll use to carry out your investigation. A sound source. The sound source automatically generates a sound wave. A frequency slider. You'll choose the frequency of the sound wave. An amplitude selector. You'll choose the initial amplitude of the sound wave. A measuring tool. You'll measure the wavelength. A data table. You'll record your results here.
Okay, so these are the things that we're going to use: a sound source, frequency slider, and amplitude selector, a measuring tool, data table. Then,
in this activity, we'll explore the relationships between wavelength and frequency and between wavelength and amplitude. How do you think these variables are related? Write your prediction in the box and then click OK.
Okay, since we want to know what is the relationship between frequency and amplitude, how they are related, and for the frequency, how it's related to wavelength, how is amplitude is related to wavelength, write your prediction. And for example, if you increase the frequency, what's going to happen to the wavelength? If you increase the amplitude, what's going to happen to the wavelength? Write your prediction. Okay. Then after we finish from this experiment, you can check if your prediction is correct or wrong. Why we are doing experiment? Because we put our prediction, what do we expect, then we're doing experiments to test if the things that we expect is correct or wrong. Okay, so our goal, we want to know what is the relationship between frequency and wavelength, amplitude and wavelength. Okay, but now what do I expect for me as Maysa, for example, or for you? What do you expect? What is the relationship between frequency and wavelength? What is the relationship between amplitude and wavelength? You have to write your prediction. Then after we finish from this experiment, we will see if our hypothesis or our prediction is correct or wrong. Let's see.
Continue to see if your prediction is correct. What is your plan for investigating the relationships between frequency and wavelength and between amplitude and wavelength? Write your plan in the box and then click OK.
So, to make the experiment, I have to put the procedure. What is the plan, my plan, how to do this experiment? The first thing that I have to do for me, for example, if I want to know what is the relationship between frequency and wavelength, I have to select a frequency, then I have to select to measure the wavelength, and I have to make the amplitude constant. This is the first step. To know the relationship between frequency and wavelength. Then, what about the relationship between amplitude and wavelength? And here I have to keep to choose any frequency and keep it constant. Then I have to increase or choose a different amplitude, and then I have to measure what is the frequency, and I have to repeat it more than one time. Let's continue. Let's see the plan.
Check your plan. Did you set a goal and include these steps? Choose a frequency and measure the resulting wavelength. Record the frequency and wavelength. Repeat for different frequencies. Choose an amplitude and measure the resulting wavelength. Record amplitude and wavelength. Repeat for different amplitudes. If your plan does not include these steps, you can change it. Once you've finished, click the next button to move on.
Okay, let's continue.
Let's start our investigation of sound waves. We'll start with the relationship between wavelength and frequency. Set the amplitude to 0.05. Keep this constant for now.
So at the beginning, I have to draw this table, frequency and wavelength. Okay, I have to choose different frequencies. Then I have to measure the wavelength for different frequencies. when you want to see the relationship between frequency and wavelength, you have to keep the amplitude constant. Okay, so I'm going, as they asked me here to put the amplitude 0.05, I'm going to choose 0.05.
Select a frequency and record it in the data table.
I'll choose here like 1, 2, 3, 4, 5 different frequencies. I'm going to start with the first frequency, which is 4000. I'm going to write it on the table, 4000 hertz. Then I'll click on it, 4000, to select the frequency.
Click to generate a sound wave.
Now I'll click to generate a sound wave that has a frequency 4000 hertz and amplitude 0.05. Okay?
Click to freeze the image. Click to activate. Measure the wavelength. Drag one end of the tool to the darkest part of a wave. Drag the other end to the darkest part of the next wave.
Let's see this one. So here I'm going to measure.
Record the wavelength. Select another frequency and repeat until the table is complete.
I'm going to measure the frequency, the wavelength. Okay, so for this one, which is 0.21 meter, this is the wavelength. I'm going to choose another frequency, the frequency that I'm going to select, which is 5000 hertz, and the amplitude should be the same, 0.05. I'm not gonna change it. Now I'm change the frequency. I'll increase the frequency. I'll generate the sound now. Now once I generate the sound, I'm going to measure the wavelength for this one. I increase the frequency. Let's do it again. Just hold on to make it more accurate. This 0.20 meter. Okay, then I'm going to change the frequency to 6000 hertz. Let's see what is the wavelength now. I'll generate the sound to see here, which is 0.9 meter. Let's continue. I'm going to change the frequency into 7000 hertz. Okay, I'll generate the sound. This is 7000. I'll see the frequency, which is 0.15 meter, as you see here. I'm going to change the frequency into 8000 hertz. Let's change it like this here, and the amplitude is the same as you see. I'll generate the sound. Okay, I generated the sound. Okay, I'll measure the distance now between them, which is 0.09 meter. Okay, now
you'll investigate the relationship between wavelength and amplitude. Set any frequency. Keep it constant for this part of the experiment.
Now I'm going to see what is the relationship between amplitude and wavelength. Here I'm going to keep the frequency the same. I'll keep
Select
the
an
frequency
amplitude and record it in the data
4000.
table.
This is the frequency 4000. Okay, amplitude I'm going to select from 0.02. I'm going to write it here. Okay, Now I'll generate the sound.
Click to freeze the image. Click
Okay.
to activate. Measure the wavelength.
Let's measure the wavelength.
Record the wavelength. Select another amplitude and repeat until the table is completed.
I'm going to select the amplitude. I'll change the amplitude here, which is 2.5, the wavelength. I'll change the amplitude into 0.05. Now I'm going to generate the sound and measure the wavelength. Okay, let's measure the wavelength. Actually, as you see, which is the same. Okay, now I'm going to increase the amplitude 0.8. I'll generate the sound. Let's see for this one. Which is the same actually, 2.5. So this is for what? The wavelength when I increase the amplitude, and this is the wavelength when I increase the frequency. Look now, let's these are the observations. You have to write this data on the table. Let's continue.
Look at your data. What happens to the wavelength as the amplitude increases? What happens to the wavelength as the frequency increases? To see your data another way, plot a line graph of frequency versus wavelength.
Okay.
Use these graphing tools to draw and plot your graph.
So
write all your conclusions in the box. When you've finished, click OK.
So here, as you see, as I increase the frequencies, the wavelength increased. But when I increase the amplitude, what's gonna happen to the wavelength? Stayed the same, stayed constant. Let's see here. Let's draw the graph. You have to draw the graph, and you have to send me the graph that you drew already. For the frequency, it was 4,000. What was the wavelength? It was 2.1. It was here. Let's put a point. It was 5,000. So it's exactly 2.2. So I'll put it here. When it was 6,000, it was how much? 0.19. Let's say it's here. When it was 7,000, it was 15, which is here. When it was 8,000, it was 0.09. So here, if I want to write the line, connect them together, as you see, as the frequency increases, the wavelength decreases, as you see here. Let's continue.
Scientists have found that as the frequency increases, the wavelength decreases. Furthermore, as the amplitude of a sound wave increases, its wavelength remains constant. However, as amplitude increases, the magnitude or loudness of the sound increases.
Okay.
How do your conclusions compare to how scientists explain this? Write your answer in the box and then click OK.
Is this our conclusion when we wrote this, when we put our data, and this is our observation? What about your expectation or your prediction? It was the same. So this is important here, very important. This one here, how the amplitude stayed constant, but as you increase the amplitude, what is this thing that increase? The magnitude or the loudness of the sound increases. Very important to know this one. Okay, so this is all about our virtual lab. If you have any question, you can send me your questions. Thank you for listening.